very clear when I do this. I take a lot of little tangents to show you a complete picture. You're not going to have to do what I'm about to do, but I want to show you how it relates to this problem, right? This is not just somebody playing with numbers, although it looks like it. But watch this. What's x plus 1 squared? Who remembers how to do that? Careful. I've doubled it. Square it. All right, and then you got to FOIL it out. X squared plus x, so plus 2x plus 1. What are the coefficients? 1, 2, 1. What's x plus 1 cubed? It'll be this thing we just got, right? Times another x plus 1. How we do it? Because that's 2 of them. If I want cubed, I got to multiply by 1 more, right? So I get x cubed plus x squared plus 2x squared. Let me do this. Plus 2x plus x plus 1. Just multiplying it all the way out, right? Is that a decent? I know I did it quickly, but x cubed plus 3x squared plus 3x plus 1. What are the coefficients? 1, 3, 3, 1. X plus 1 to the 4th. 1, 4, 6, 4, 1. Right. To the 5th. Now how do I keep getting these numbers? Yeah, 1 plus 3 is 4. 3 plus 3, 6. So how do I get the next level? 1's on the outside. 1 plus 4, 5. You can do it, Jeff. There you go. And 1 on the outside. And you can keep going. Anybody know what this is called? I don't think they tell you. Almost close. It's Pascal's triangle. Oh. Yeah, Pascal. If any of you guys know the programming language C, the computer programming language C or C++? Anybody know any computer programming? No. Well, there's a program, and I'm the last one in the college. They started teaching C++. I took Pascal. It was another programming language before that. It was named after that dude. He did a lot of little nifty things, and this is just kind of nifty, just playing with numbers, and then it has an application in algebra stuff. Okay. And that pretty much answers the question, right? I mean, that's what they asked was what the next level was.
Okay. So how did you know to go to that step?
Which step?
To use the x plus 1 squared.
That's what these relate to. And the theory behind this, why does this relate to this, is a little more than I can get into right now. But it has to do with the fact that, look here, there's the 1 plus 2 to make the 3. 1 plus 2 to make the 3. Right. So they see the pattern between what happens here and what happens there, and that's just a quick way of figuring out what your coefficient should be. Yeah. So you can save some time. You have to multiply it all the way out. I can just go straight to it. Okay. Any other questions from 1, 1 or 1, 2?
Can you do 32? 1, 1.
What's the pattern there? Every time, that's that triangular numbers one.
Yeah.
So 1 plus 2 here is 3. And then of course you add another 3 at the end. So 3 plus 3, 6. So I keep adding. So I add 2, I add 3. The next one I'm going to have to add 4, add 5. That's the pattern, right? Yeah. Because every time I want to make a new base, it's got to be one bigger than the one above it. So it's not too long, and so it's not the same size. I want it to be one bigger, so it makes a nice triangle. Okay. So that's the pattern. If you just keep going with the pattern, you'll see whether or not the number they give you is a triangular number. Cool.
Question for the 6, please. Just tell me what is the chapter.
So that one, I think we did an example of it last time, but it says the product of any two counting numbers is divisible by 2.
Number is number, next number, or
A counting number starts at 1 and goes 2, 3.
Okay, so if I try 3.
Okay? So the product of any two. So you have to pick two counting numbers, take the product,
So
and see if it's divisible by 2.
So should we take 3, next is 4,
No, no, no.
or
Any two counting numbers.
Oh, any 2, okay.
Okay, cool.
Okay.
So not 1 and then the next one, just any 2.
Any,
Cool.
okay, thank you.
Otherwise, you're right. That would drive me insane because it would. the product of any counting number and the next one up is always divisible by 2. That's true. Because either the one you pick is odd and the next one's even, or the one you pick is even, the next one, there's an even number, it's got to be divisible by 2 then. So that would be really evil if it said. Okay, cool. So we're going to finish up chapter 1 today. I've got a little video I want to show you. How many people have heard of Abbott and Costello? Okay, so a big chunk in the middle have not. So today you're going to be exposed to the comedic math stylings of Abbott and Costello. They're actually really well known for little bits about math and playing around with numbers. Thankfully, they were known for a lot more than that, for those of you not as interested in math as I am. Right? But we'll see if you like it. If you don't, it's too bad. But just to finish this section out, the last section, I think I kind of not warned you, but let you know, the last section is going to be a lot more straightforward than 1.1 or 1.2 was. Those had a lot of new stuff in it. 1.3, I'm thinking, should be a lot more straightforward. Let's just try a few out straight out of the homework to see what they look like. And actually, I'm just going to plop a few up here and see what you guys do. Yeah, so like number 5, this is page 30.
This is for 1.3.
Yeah, 1.3. The average tuition at a private college increased by 5.7% from 2004 to 2005. In 2004, it cost $27,461 on average to attend one of these colleges. And that's the one I attended. It was crazy. It went from $8,000 when I started, and then the last year was $24,000 a year. The last year I went there. It's like, thank the gods for loans and scholarships. Determine the average tuition in 2005. Right, so it increased by 5.7%. This is not a word problem at all. It's just, can you do the correct operation with the numbers they give you? That's all these are. Oh, just a second.
5.7 over 100.
Is this estimation or is this just
No, this is, give me the answer, the exact answer.
5.7 over 100 equals
Well,
is over of, which is maybe cross multiply.
okay, you could do that. I mean, that's fine. You could do it a little more straightforward than that, yeah.
1.057 times 27,000.
All right, a man after my own heart. So you don't have to do it this way, but he's saying, what do I want to do to really get the end result? Should this number be higher or lower? It's obviously going to be higher because it's going up by this. How much did it go up by, though? So here's what it is now. How do I figure out how much it goes up by? Multiply what?
The percentage.
5.7% times this. So you got to make that into a decimal, right? So what you're saying is, what would you do then once you did that? So you want to take 5.7% of how much it costs here, right? So you got to change it to a decimal. What would that be as a decimal? Beautiful, 0.057. Don't make it 0.57. That would mean it went up by 57%. Holy what? All right, so 0.057 times this. And a little quick note. This is section 1.3. You don't estimate anything. Section 1.2, you estimate everything, right? So in a test or quiz, I'm going to be very, very explicit on what I want you to estimate and what I don't want you to estimate, right? So I make it kind of vague. What do you get there? What number do you get there? Somebody help me out.
1,565.6 or 0.277.
0.277?
Yeah.
So 0.28?
Yeah.
We can round a little. It's not really estimating. It's just rounding to 2 places for money. What do I do with that number? Add it. So what you said, what's your name? Keith. Keith said, screw all that. Let me just, I know I'm going to have to add this to a whole one of these. So he said, if I just take 1.057 times this, that's the answer. Because I add one whole thing plus 0.057 of that thing So you just said 1.057 times that is the answer. If you don't quite understand why that works, don't worry about it. Do it this way. This is beautiful. But that is really cool. That's the more you understand, the less you have to do. That's that idea. Right? I like to say that a lot. So he kind of understands how percentages work. He has to do less. So this is not that much. What do I do with that number now? Add it to what it was. Equals whatever the hell it is now. Cool. Is that all right? Okay, so there's always more than one way to go about doing these. What about number, so what do you get, like $29,000, $26, 28 cents? Okay. Number, let's see, oh, okay, here we go. Number 11. So, have you ever noticed the names in math books? There used to be Meg and Bob and Sam. So number 11, Emily Putnam wants to purchase a computer that sells for $1,250. So $1,250 computer. She can either pay that total amount at the checkout, or she can agree to pay, where'd it go? $120 down and $80 a month for 15 months. How much money can she save if she just pays it all right there? So don't say anything out loud. Take a minute and see if you can work that out. So she can either pay for the whole thing up front, or she could do this plan. How much money would she save if she paid the whole thing up front? So don't say anything out loud yet. So you guys can maybe see how these are really like algebra problems, just forward instead of backward. So you can imagine somebody making an algebra problem out of this, right? You could. But this is not an algebra problem. It's not a word problem. It's just, can you do the numbers correctly? So they gave me that number directly, so I know that's one way you can go. How much total money would this be? This would be $120 down plus $80 a month for 15 months. Well, $1,320, yeah. So of course, how do you figure out how much you would save? Subtract. I mean, that's all this section is about. Don't make more out of it. No need for algebra. Don't start bringing x's in there. Don't start drawing little rectangles or whatever. Right? None of that needed. Just very straightforward. Can you do the right math with the numbers they gave you? So here at 1320 minus 1250, 70. So you could save $70. So actually, that sounds decent. Right, if you ever stop and calculate your if you have a car payment you're making, the amount you actually end up paying in interest is sometimes obscene. Right? For credit cards, you want to talk about obscene. How much paying interest on those is just stupid. Okay, one more out of that section because this is my favorite ones, and then we're going to watch a little clip of a Abbott Costello movie. We'll see if it has any relationship to the math I'm doing. But, let me ask you this. Let me see if you can get this. If you know I have 4 numbers, and they average to be 50, can you tell me anything about those 4 numbers? I have 4 numbers and they average to be 50. So the easiest way for that to happen is